Hello guys, welcome back to my YouTube channel. Today we're gonna talk about computer network basics, remote access and NAT. Remote access. As you can see, you can be in Seattle and you wanna try to remote access to Tokyo, Japan with the switch. You can do it. And Telnet is a network protocol that provides command line access to remote devices over port 23, used for configuring network devices, testing connectivity, and troubleshooting services. Lacks encryption, making it usable for a secure environment, often replaced by SSH, ideal for trusted or isolated networks with minimal security concern. Virtual terminal lines. VTY lines are logical interface on network devices for remote access through Telnet or SSH. They are enable administrators to configure and manage devices via command line interface. Support multiple simultaneous remote session, providing flexibility for devices management. Security can be enhanced using ACL, strong password, and encryption protocols like SSH. How to configure Telnet? First is to enable Telnet access. Second is to set up authentication. Third is assign an IP address, and step 4 and verify connectivity. As you can see here, this is how you configure that Telnet. Set hostname and domain name, create local username, and enable Telnet on VTY lines, and configure an interface with IP. Is it a secure shell? A protocol for encrypted remote access and management over unsecured networks. Default port 22, using client-server communication. Authentication support password-based and key-based method. Key use cases: remote login, file transfer, and tunneling and automation. How SSH works? Operates over TCP port 22. Uses publicly cryptographic for authentication. Supports password-based and key-based login. Data is encrypted and end-to-end during the session. SSH versus Telnet. SSH encrypts data. Telnet sends data in plain text. SSH uses port 22. Telnet uses port 23. SSH is secure and safe over the internet. Telnet is outdated and mostly used in labs or testing environment. As you can see here, this is how you SSH config right here. And you always go to the app and enter the username and hostname or IP devices so you can connect. Now we're gonna do remote access demo in Packet Tracer. Alright guys, now I'm going to show you how to configure Telnet. I have a simple setup. I have a PC and a router. So far I gave the PC an IP address. I linked it to the default gateway which I gave to the interface of this router. So if you want to see what I configure for my PC, I gave my PC IPv4 address 192.168.20.2 with a subnet mask of 255.255.255.0 with a default gateway of 192.168.20.1. And then if you go to open the router, I gave the router name 1. Now I go ahead and type this command. So for my example, I'll use the domain name. As you can see, I added the IP domain Daryl.com. Now I'm gonna type in username Daryl, password Daryl123, which is this command. Enter. Now I'm going to type in line VTY04 and click enter. Now we're in the config for the terminal line. I'm gonna type in password, and I'm typing the password that I just created. Enter. I'm gonna type in login local. Enter. And now I'm gonna type transport input telnet, and we're gonna enter this. Now I'm going to the PC now. I'm going to the command prompt. I'm gonna type in telnet 92.168.20.1, which is the default gateway for this router, and it's asking for the username that we created. It's also asking for the password that we created. I type in Daryl123. Enter. Now, as you can see, I'm in the interface CLI for router 1. Here's the thing, if I type enable, no password set. So now I'm going back to the router, and I'm gonna type in enable password Daryl123. Now we're gonna enter, and I'll go back to the PC, and now we go back to enable. Now it's asking for the password. You type our password Daryl123, enter. As you can see, we have access to the router. And just to show you, I'm gonna show run. And it shows me all the running configuration from the router 1 hostname right here. And right here, IP address 192.168.20.1. And this is the interface of this router. You can see it in your PC, which is really nice. We can also say show IP route. It will show you the routing table. I can configure the terminal. I can go to the interface. However, you want to stay away from shutting down this interface because it can cause an outage. And you can lose the connection to the router. So that means you can't edit anything from the PC to the router. And that is Telnet, a very cool remote access protocols. Enables you to remote access and switch from your home devices. But like I said before, it lacks a lot of security features, which makes it really obsolete in today's computer networking world. So now we're gonna talk about SSH. This is the same exact setup. We just have same IP address and everything. I just removed the old commands, and now we're going to add the SSH command, which is all this command. So I'm going to the router. I'm already in a config mode, and the first one is IP domain name website name.com, and I'm going to run IP domain name daryl.com. Enter. Now I'm going to run username Daryl and password Daryl123. So enter. We're gonna do crypto key. We're gonna go crypto key generate RSE. And how many bits in modules do you want? You can add 5112 or 1024, but I'm just gonna add 1034 for higher bit security. Enter. Nearing 1024-bit RSE will be non-exportable. Okay. Now we're gonna add next one, the IP is version 2. Enter. Now that we're still in configure terminal, we're gonna add the line VTY04. We're gonna add the transport input SSH. Enter. And we're gonna add right login local. Enter. We're going to add show IP SSH. Enter. And as you can see, we have SSH enabled version 2.0 and authentication timeout. Now we're coming back to the PC 0. Now we're gonna add a command to get remote access for SSH space -L space Daryl space 192.168.20.1, and that is the router's IP that we're connected to. And it's asking for our password, and the password was Daryl123. Enter. And now we're in router 1. We type enable. I already enabled the password as before, so it's asking for a password again, but we already know that we added the password Daryl123. Enter. As you can see, we SSH in this router, so if we type show run, we have the result just like before, the telnet that we did. There's the interface information right there. Show IP route, and there's the route that we have. There's the routing table for the router. And that's how to configure SSH. Very similar to Telnet. We use more in the modern era, but regardless, it's very cool protocol that gives you ability to remote access routers and switch from your home devices. Now I'm going to move to NAT. Now that we're done with remote access, we're gonna talk about NAT, Network Address Translation. Maps provide IP address to public IPs. Allow multiple devices on local network to share single public IP. Provides IP address conservation and simplifies internet access. Maps private IPs, enhancing network security. This is what NAT diagram looks like. You have a private network, goes to public network, and a router in the middle. Benefits of NAT: reduce demand for IPv4 address by conserving public IP, adds a layer of security by hiding internal network details, simplifies network management for devices accessing the internet, supports seamless communication between private and public networks. Types of NAT: static NAT maps one private IP to one public IP. Dynamic NAT uses a pool public IP to assign it dynamically. PAT, port address translation, maps many private IPs to one public IP using ports. PAT is the most common NAT type for home and business networks. Home routers enabling internet access for multiple devices. Business managing shared internet connection securely. Data centers hosting servers behind private IPs, migrating legacy system in environment within limited public IPs. Static NAT config. As you can see, we have the 10.0.0.1 goes to the IP NAT inside source static. 10.0.0.0.1 to 210.12.1 goes to public. NAT address types. Inside local, the private IP assigned to a device inside the local network. Inside global, the public IP address represents the internal device to the outside world. Outside local, the IP address of an external device is unpaired to the internal network. Outside global, the actual public IP address of the external devices on the internet. Dynamic NAT. Translate a private IP address to a pool of public IP requires an access control less ECL to specify which internal addresses are eligible for translation. Uses a defined NAT pool from which public IPs are dynamically assigned. Supports one-to-one address mapping each internal device's needs for free public IP to access internal networks. Here's how you configure Port Address Translation PAT. Port Address Translation PAT is the type of NAT that maps multiple private IPs to a single public IP. Differentiates connections using unique source port numbers commonly used in home and business networks who share one public IP. Operates on layer 4, tracking traffic via TCP UDP ports. And this is how the PAT diagram looks like. And now we're gonna do a packet tracer demo. And now we're gonna configure NAT. This is my setup. We have a local area network in green, the wide area in yellow, or the internet in yellow. These are the commands. They are pretty simple. You go to the middle router, open CLI, and you type in IP NAT inside for the inside and IP NAT outside for the outside internet. This PC is already configured with the IP address, and the router has been set up with IP addresses. Static route has been set up by IDF. IDF has been set up. So if you wanna see if to test it, we can ping this interface right here. As you can see, success rate is 80%. That means we're having a reply back. The ping works. So now we go to the middle router, and I'm going to the inside of the interface, which is gigabit 0/0/0. So interface gigabit internet 0/0/0. Enter. And I'm gonna type in IP NAT inside and click enter. And I'm gonna exit, and I'm going to the opposite side of interface, which is gigabit 0/0/1, and interface gigabit internet 0/0/1. Enter. And now I will type in IP NAT outside. Enter. And I'll go exit. And now I'm going to the general config mode, and I'm gonna use this command. And now I'm gonna type show IP NAT translation. And right there it shows the NAT table, and the command is IP NAT inside source static, because we are using static 192.168.10.2 because that's the end device, the private end device, and 10.10.10.2, which is the router public IP address that the internet will receive. Actually, we're gonna do a ping test first, and we're gonna try to ping the default gateway, and I will ping the public IP, and the public IP come back, and those went through. And then I'm going back to the router, and I'm gonna type the show IP NAT translation again. And again, show IP NAT translation. You can see because of the ping request, there's been more data added to the table. And so for those header inside global, inside local, outside local, outside global, inside local, it's just the global is the public showing the internal device to the outside. Outside local is the external device IP as it appears on the internal network. And outside global is the public IP of the internal device on the internet. Kind of confusing, but that's the gist of it. And that's how you configure static NAT. This is going to be the setup for our PAT. By the way, PAT is port address translation. Same setup as last time, except we added 2 new PC connected to the switch, which is connected to the router, which is connected to the router 1. The ping are working between end devices and the router. The interfaces are up, and they have been configured with an IP address. And there's also a static route from 10.10.10.2 to 192.168.10.1. So now we're gonna do, we go back to the middle router, enable. So we will set up an IP inside in this interface and an IP outside in this interface. We enter to the gigabit interface, gigabit 0/0/0, enter, and then IP NAT inside, enter, exit. And now we go to interface gigabit 0/0/1, enter, and we're gonna configure it IP NAT outside, enter, and exit. Now we're going back to general config mode, and now we're gonna create an access list. We're typing access list 1 permit 192.168.0.0, 0.0.255.255 with the wildcard mask, and I will enter this. IP NAT inside source list 1 for our access list 1. Less interface gigabit internet 0/0/1, which is the port for the outside interface. And then overload. And then we're going to enter that. And now I'm going to do some ping tests. So we're ping this one, ping that one, and then ping this one, and then we're gonna ping this one, and then we're going back to our middle router, and we're gonna do show IP NAT translation. And now we have our NAT table. As you can see which PC sent the ping request right here, the inside local, and the left right here are the public IP address that are sent out to the internet. And that right there, you guys, is how you configure PAT. And that's it for this video, guys. Thank you for watching. Today we went over NAT and we went over remote access. Very informative stuff. Hope you guys learned something. I will see you guys in the next video. Bye.